All right, guys, so I'm gonna try to get through as many questions as I can today from the review, so we'll see how far I get here. But number one, we are supposed to describe the transformations that this function would have on the graph of y equals x squared, and then actually graph it. I do have a graph here of y equals x squared that you need to memorize. You need to know these 5 coordinate points right here. They do not change for the graph of y equals x squared. All right, so first, does this graph have a vertical dilation? Yes. If there's a number that is multiplying in front, that's our vertical dilation, so it's a factor of 2. Now, dilations multiply, translations add, so this number is going to multiply our y coordinates. If it was inside, it would multiply with x. This is going to multiply the y coordinates. So, I am going to go through this and double the y's here. So negative 2 comma 4 is now negative 2 comma 8. So it's just the y coordinates 8. Negative 1 comma 1, if you double the y, you get negative 1 comma 2. If you double 0, it doesn't move. Double 1, now it's 2. And then double 4, that would also be 8. And so it looks something like this. Again, I'm not using graph paper, so some of these points are off by just a little bit here. So that's our first transformation. Now we're going to look and see, are there any vertical translations? So again, vertical is always outside, horizontal is inside. Dilations multiply, translations add or subtract. And so this is a vertical translation right here. And it's on the outside, so outside moves it up or down. It's going to move our graph down by 3. All right, horizontal dilation. So there would have to be a number inside the parentheses that is multiplying with x besides 1. So 1 doesn't count because it's not going to change the size of the function. All right, so something other than 1 that we're multiplying x with. So there's no horizontal dilation. All right, horizontal translation. So again, translation is adding or subtracting. Horizontal is inside with x. All right, so there is a horizontal translation right here. That is going to, remember, inside is opposite, so a minus actually moves the graph to the right by 1. And so I'm going to do these last 2 transformations simultaneously. Every point's going to go right 1, down 3. Okay, so let me do that here in red. So this point goes right 1, down 1, 2, 3. It's going to be out. Negative 1 comma 5 would be the coordinate point now. All right, and then this one, if we go right 1 space down 1, 2, 3, it's at 0, negative 1. Right 1, down 3. Right 1 and down 3. And the last one, right 1, down 3. Be about right there. Again, I'm not using graph paper, but this is about as accurate as I can get it up here. And so that's our graph. All right, number 2. So I'm going to start with this negative out in front. All right, so a negative out in front is always a reflection across the x-axis. Okay, so G, we have a reflection. I'm asking which of these. And so really, in the directions, we should be circling the ones where the transformation does occur. Okay, so there's a reflection across the x-axis here. There is not a reflection across the y. That would be a negative on the inside, and that's not going to happen with quadratics because it's already symmetric here about the y. So we're not going to have any reflections over the y-axis for quadratic functions. Okay, so if I was to do that transformation first, I'll just start with this one. It's just going to flip the graph down. So what does that look like? Well, 1, 2, 3, 4. So negative 2 comma 4 is now at negative 2, negative 4. And I didn't space that out properly. Let me try that again. So 1, 2, 3, 4. Okay, so now it's right here. Here, this one doesn't move. There, and they are reflected over the x-axis, okay? And again, I missed the points, but that's all right. So that is our reflection over the x. Now we're going to figure out, is there a vertical dilation or horizontal dilation? Is there both? Neither? What is this? So there is vertical dilations are outside. The number outside, though, is a 1. That doesn't change it. The negative doesn't count because that was a reflection. So the 1 does not change the size, so there's no vertical dilation. All right, and then let's see, horizontal dilation. There is a number that's multiplied. Remember, dilation is always multiplying, and horizontal is inside the parentheses. So there's a horizontal dilation, but inside is always opposite. So we're actually going to flip. It was 2 over 1. We're going to flip it into 1 over 2. Now, what does that mean? Again, horizontal is going to multiply the x's. So we're going to multiply the x's by 1/2. Or same thing, divided by the x's by 2. All right, so let's do that. Let's divide all of our x coordinates by 2. So here the x coordinate's -2. When I divide the x by 2, I get -1 for the x. So these will move side to side if they move at all. All right, the x value was -1 here. Now the x value is -1/2. 0 doesn't move. 0 divided by 2 is still 0. 1 divided by 2 is 1/2, and 2 divided by 2 is 1, and so it looks like this. Again, a horizontal dilation with the reflection across the x-axis. All right, and that there was a transformation there. All right, number 3. Same idea here, but we're not working with x squared. We're working with a generic function. Okay, so a 2 out front that's being multiplied. Remember, multiplying is always a dilation. And it's on the outside, which is vertical. All right, and so this 2 is a vertical dilation by a factor of 2. The adding and subtracting are going to be transformations. Inside is horizontal, outside is vertical. So we have I'm going to start inside. So we have a horizontal translation. Inside is opposite, so a +1 moves it left. Okay, so horizontal translation, left 1. Vertical translation, the plus moves it up, so it's up 3. It's these 3. There is no horizontal dilation because, again, there's a 1 right there, and that 1 does not change the size of the function. All right, up next, now we're getting into listing out information here. So we have to recognize what form our quadratic function is in. This is vertex form right here. This is left 4, down 2. So on a graph, our vertex is left 4, down 2. All right, we know that it's going to open up because the leading coefficient is positive. If that number is positive, it opens up. If it's negative, it opens down. And so without getting all of the points exact, it looks something like this. Okay, that's a rough sketch. We could go step by step like we did on the last ones, but just to get a quick graph, vertex form, left 4, down 2. So our vertex is at -4, 2. The axis of symmetry is always the x-coordinate of the vertex. We just take that value, x equals that, because it's the line right there, which is the line x equals -4. That's our axis of symmetry. How does this open? Well, we already said it opens up because the leading coefficient is positive. Now, anytime a graph opens up, the vertex is a minimum. It's at the bottom. So we're just going to circle minimum here. If it opened down, the vertex would be a maximum then. All right, when is this graph increasing, decreasing, and what is the range? So I'm asking for different notations here. If you ever forget on a test, remember you're allowed to ask me about which notation is which. But we're looking for increasing at first. So let's start off with just labeling on this graph when it's increasing and decreasing. Okay, so you go from left to right. Even though these are both going up, it's not always increasing because from left to right, the graph is going down at first to the vertex, and then it switches, and the graph is going up. Okay, so this green portion is increasing, the red portion is decreasing. Now, different notations. Okay, I'm just going to list out all of them. I know that there's some struggle here. I like to list interval notation first. I think it's the easiest. We're going to start with increasing. Okay, so increasing in interval notation, we always want to do left x, comma, right x. Write that down. Left x, comma, right x. That's interval notation. All right. So what's the x coordinate here? Well, the x coordinate is -4, comma, the y coordinate, or sorry, the rightmost x coordinate rather. So leftmost x is -4. The rightmost x, if this graph is going right and up, it's approaching positive infinity, comma, positive infinity, but it's the x that we want, even though they're the same. Okay, so -4, comma, infinity. That's our interval where it's increasing. Now, inequality notation is either going to be x is greater than or less than. So to figure that out, okay, if you're not sure how this translates to an inequality, draw a number line. We want -4 to positive infinity. That's this portion. So how do we write that as an inequality? Well, these are all the values to the right of -4 or greater than -4. So we're going to point our symbol to the right. That means greater than. Okay, this is inequality right here. All the values to the right of -4 towards positive infinity, right? Or all the values greater than, same thing, -4. That's our inequality notation. Decreasing now. All right, so decreasing, let's do interval notation. Let me erase a few things first. Okay, so decreasing, we want to do same thing, left comma right. So here, this graph is approaching -infinity, positive infinity, because it's going left forever, up forever. That's the coordinate point it's headed towards. We want the x coordinate for all of these, except for the range. All right, so leftmost x always goes first on this interval, comma, the rightmost x, where does the red stop? It stops at -4. So that's the interval in interval notation. That's our answer. It didn't ask for it, but if we were to put this on a number line, it would be this portion over here, which is less than instead of greater than. So if we were to do this one, it would be x is less than -4. All right, lastly, the range. The range is always the y coordinates. The only one we use the y for. It's the y coordinates. I don't know why that's still there. We want to do the bottom y, comma, the top y. Oops, y. There we go. Bottom y, comma, top y. So the bottom y is right here. Its y coordinate is -2. So in interval notation, I'm going to put -2 first, comma, the top y coordinate, there's kind of two of them, but they're the same numbers, right? They're both positive infinity. All right, and so that's our top y coordinate of infinity. And so that's our interval. The reason I'm including that -2 is because I'm listing out what values are actually, what y values are actually on this graph. -2 is a y value on the graph, as are all the ones here, but they're included in between these two. All right, so make sure you include that -2 for the range, or whatever the vertex is you want to include. All right, up next, so this is standard form. It is ax squared plus bx plus c. All right, so whenever we're given standard, to get the vertex, we have a formula. Our formula is x equals -b over 2a. All right, so here b is -8. So we have -8 over a is going to be -4. So that being said, the numerator is just 8, +8. The denominator is -8 when we multiply. 8 divided by 8 is 1, and it's going to be negative because there's one negative. This is the x coordinate of the vertex. So I'm going to put a -1 right here. To get the y coordinate, we have to now plug that -1 we just got into our equation for x. So I'm going to do that right here. We've got a -4 times -1 squared minus 8 times -1 minus 2. Order of operations, we want to do the exponent before we multiply. Okay, so -1 squared is +1. Now we're ready to multiply, so -4 times 1 is -4. -8 times -1 is +8, and minus 2. -4 plus 8 is 4. 4 minus 2 is 2. That's our y coordinate. Now our axis of symmetry, that is always x equals the x coordinate, -1. Now, which direction will this open? Well, there's a negative leading coefficient, therefore it opens down. All right, I'm going to go ahead and sketch the graph because it'll help us in a minute. Oops. Let's do that. It'll help us in a second here. So we know the vertex is left 1 and up 2. We know the graph opens down. That's really all that we need to be accurate on this one. So this point is going to be a maximum. I was asking about the vertex. The vertex is the highest point, so it's a maximum. Now, increasing in interval notation. So let's see. The graph is going to be increasing right here from left to right. Even though it's pointed down from left to right, the graph is going up. And then it switches and it decreases right here. From left to right, it's going down. All right, so let's tackle increasing first. Interval notation. So I'm going to list out some coordinate points here. This is negative, comma, negative infinity. This is positive, comma, negative infinity. And the vertex is negative 1, comma, 2. Remember, for the majority of these questions, except for range, we want the x coordinates. X, x, x. Now, increasing, I always like to start off with interval if I'm not sure what the inequality is. So remember, interval is left, comma, right. So increasing would be negative infinity to negative 1. Now you may not have to draw the number line if you already know that these are the values to the left of negative 1, we could just write x is less than negative 1. Or if you're not sure, again, draw your number line. Here's negative 1. We are shading the values to the left of negative 1. This is where negative infinity is. So we're shading over here. So we want to make sure that our inequality is pointed the direction that we shade. Okay? All the values left of or less than negative 1. That's our increasing inequality notation. Now, where is it decreasing in interval notation? So decreasing, again, is the red part, left x, comma, right x. So negative 1, comma, infinity. If we needed it in inequality, it would be x is greater than negative 1 because we would end up shading this part over here, which is to the right. And lastly, range, interval notation. Again, we want to do bottom y, comma, top y. So the bottom y's are both negative infinity. So that's going to go first. Comma, the top y is at the maximum, which is 2, and it'll go in a bracket. All right, number 6, same exact thing. Just know that a is negative 1. Right, there's a negative 1 in front of the x squared. So it's in standard, so our formula is x equals negative b over 2 times a. That gives us negative 4 over negative 2, which is positive 2. All right, that's the x coordinate of our vertex. We want to plug this in for our x's. So it's negative, parentheses 2 is squared, plus 4 times 2, plus 2. All right, so we're plugging in 2's into the x's in parentheses. Again, do not make that 2 negative. That's multiplying. We want to square first, then multiply by the negative 1 on the outside. So 2 squared is 4, times negative 1 is negative 4. 4 times 2 is plus 8, plus 2. So negative 4 plus 8 is 4, plus 2 is 6. That's our y coordinate. All right, axis symmetry. We know that it's the x equals the x coordinate. Negative leading coefficient, it opens down. Anything that opens down has a maximum at the vertex. Now, as far as the rest of this, again, we have to have a rough graph drawn here. So let's see. Vertex is at 2, 1, 2, 3, 4, 5, 6. And it opens down. I'm going to go through this one a little bit faster here, but increasing here, this is almost exactly like the last problem, increasing, then decreasing. All right, so increasing would be negative infinity, comma 2. If we did that on a number line, it would end up being x is less than 2. X is less than 2. Decreasing, left, comma right, would be 2, comma infinity. And that's where it's decreasing. All right, last one that I'm going to go over in this video, and maybe I'll get to the other ones next week. Maybe not, we'll see. So this is in factored form or intercept form. When it's in this form, we want to set what's in the parentheses equal to 0. set x plus 3 equal to 0, and subtract 3, and set x minus 1 equal to 0, and add 1. We don't use the 2 because there's no x there. If there was, I would set 2x equal to 0 though. All right, so we are going to, these are our zeros. So on a graph, there's an x-intercept or a 0 at -3 and at +1. The vertex is always halfway in between, so you could just count that way, or you could average those two values together by adding them and cutting it in half. -2 over 2 is -1. That is the x coordinate. We don't know where to put the y coordinate yet, but it's going to be somewhere where x is -1. That also gives us the axis symmetry as x equals -1. To get the y coordinate of the vertex, we've got to replace both x's with -1s. So here's how this looks, and these are all being multiplied. So what parentheses means we're multiplying the things together. So it's 2 times -1 plus 3 times -1 minus 1. I'm just replacing both x's with that -1. Well, -1 plus 3 is 2, so this is 2 right here. Okay, this part's 2. And this is going to give us -2. So let's just make that a -2. All right, again, we're not adding here, we are multiplying. So 2 times 2 is 4, times -2 is -8. So our vertex is left 1 and down 8. I'm just going to say that's right here at -8. Now, we don't need any other points, but we do have the zeros in the correct spot here. So this graph, okay, we can go through those points. And obviously the graph has to open up. We know that because A is positive and because the vertex is below the 0, so it opens up. That point, the vertex is at the bottom of the graph, so it's a minimum. Right there, excuse me, minimum. Now, increasing versus decreasing. Again, we've done this a lot already. Decreasing right here. Oops. Right here, decreasing. Increasing right here. So, interval notation for increasing would be -1 because it's the x to positive infinity. If we put that on a number line, we're going to end up with x is greater than -1. I'm kind of skipping some of the explanation here because it was same as the last 3 problems. Okay. Decreasing in interval notation, that would be -infinity to -1. Again, it's the leftmost x comma the rightmost x. All right. What I will spend more time on now is the positive versus negative. Okay. Positive versus negative. You should be prepared for either interval or inequality here, even though these both ask inequality. All right, so let me erase a little bit. So positive just means above the x-axis, okay? And negative means below the x-axis. So when is this graph positive? Well, it's positive here and here. When is it negative? It's negative down here. It's below the x-axis. So I'm going to start with negative. That one's a little bit easier. Okay. So this, when it's one interval, inequality notation is very similar to interval notation. So let me show you what I mean. When it's negative, so again, one interval here, it's not split up like the one is up here. We just list the leftmost x coordinate, comma the rightmost x coordinate. That's interval notation. If you want to throw it on a number line, it's the values in between -3 and 1, right here. Okay. Whenever it's one interval, where you put it on a number line or on a graph, when it's one interval, inequality notation looks almost the same. It's -3 is less than or equal to x is less than or equal to 1. Okay. If it's one interval in between two values, we write it like this. That's our inequality notation. All right. So that's the answer for negative. When is it positive? So that's a little more work. There's two intervals here. So let's do this in interval notation first. Okay, so positive. Remember, we want to do left comma right. The left x is -infinity, even though the y is positive. We want the x. Okay, so left comma right. So the positive would be -infinity to -3. And then left comma right would be 1 to positive infinity. That's an interval. Now, how do we put that in inequality? Well, think about it on a number line. We have, this is left of -3. This is right of 1. Okay, so it's 2. So it won't be like this one where we listed it as one interval. We have to write this as 2 of them. These are the values left of or less than -3. These are the values right of or greater than +1. And we leave it like this. We don't make it one interval because it's not. It's 2 separate intervals here. All right, so hopefully that was helpful. Again, I don't know if I'll get to post the rest or not, but you guys will be able to ask questions on Monday. And hey, stay flawless.